Dear friends, Mass Aspirants is a collective of mathematics students, research scholars, and teachers across India, initiated by myself in 2017. And we used to organize online problem solving sessions to help the students who prepare for different national level competitive examinations. As a part of that series, today we have a session on ordinary differential equations, and we are having Mr. Muhammed Rafeek, a research scholar from Central University of Karnataka, is with us to handle a session on ordinary differential equations. Today, he will discuss selected problems from the question papers of JAM examination 2022 and 2023 with you. I would like to express my sincere thanks and gratitude to Mr. Muhammad Rafeek for being with us. He has cleared CSER NET examination and a recipient of DST Inspire Fellowship, currently pursuing PhD at Central University of Karnataka. I welcome everyone to this program. Welcome, Rafeek.
Yeah, thank you, sir, for giving this opportunity. Yes, now we will start our this question solving problem. This is my third class in JAM with Max Experience group. So this is first time I am taking the class in the ODE, ordinary differential equation. That also especially for the JAM students. In this section, I am going to see the previous year's problems in ordinary differential equation. Yes, see the first problem. This is JAM 2020. Anyway, first problem. Consider the initial value problem. dy by dx plus alpha y is equal to 0. Y of 0 is equal to 1. Where alpha belongs to R, then there is an alpha such that y of 1 equal to 0. There is a unique alpha such that limit x tends to infinity y of x is equal to 0. There is no alpha such that y of 2 is equal to 1. There is a unique alpha such that y of 1 is equal to 2. This is JAM 2023 question, and especially this is a 1 mark question. Okay, anyway, we have the DE, also dy by dx plus alpha y is equal to 0. dy by dx plus alpha y is equal to 0. And this is an initial value problem. Y of 0 is equal to 1. Yes. This we can solve by several methods. I am going to see through the variable separable method. So dy by dx is equal to minus alpha y. I can written as dy by dx is equal to minus alpha y. So dy by y is equal to minus alpha dx. dy by y is equal to minus alpha dx. So if I integrate on both sides, what I can have? Log y, log mod y is equal to minus alpha x plus the constant of integration. So that means y equal to some c e raised to minus alpha x. E raised to minus alpha x plus c will come. So that I can written as c into e raised to minus alpha x. Or otherwise, this I took c1. Then e raised to c1 I take as a constant c. Then it become y equal to e raised to minus alpha x. Okay. Now I am substituting my condition. See here they are given y of 0 is equal to 1. So 1 is equal to c e raised to 0. E raised to 0 is 1. So I will get c equal to 1. So my solution is now y equal to e raised to minus alpha x. This is my particular solution now. E raised to minus alpha x means y of x is equal to 1 by e raised to alpha x. This is the solution of IVP. Now let us see the condition. There is an alpha such that y of 1 equal to 0. There is an alpha such that y of 1 equal to 0 implies y of 1 equal to 0 implies 1 by e raised to alpha. Yes, e raised to alpha. So 1 by e raised to alpha means what you will get? 1 is equal to 0. This is never possible. So option 1 is an incorrect option. Now limit x tends to infinity. See the second. What was the second option? There is a unique alpha such that limit x tends to infinity, y of x is equal to 0. See, limit x tends to infinity, y of x. Y of x is nothing but e raised to minus alpha x. Means what you will get? E raised to minus infinity. E raised to minus infinity is always 0. Never, it is not any number, but e raised to minus alpha is minus infinity is always 0. So there is no unique. You have infinitely many alpha such that your limit extends to infinity, e raised to minus alpha x is equal to 0. So this option also incorrect. Next, what was the next section? There is no alpha such that y of 2 is equal to 1. Yes, implies there is no alpha such that y of 2 is equal to 1. So y of 2 become, what you will have? Y of 2 is equal to 1 by e raised to 2 alpha. E raised to 2 alpha is equal to 1. So 1 is equal to e raised to 2 alpha. 1 is equal to e raised to 2 alpha. 2 alpha is equal to log 1. Log 1 means log 1 is equal to 0. Implies alpha is equal to 0. Yes, there is, but they are telling there is no alpha such that. No, there is an alpha, that alpha is equal to 0 such that you will get y of 2 is equal to 1. So this option also incorrect. Then there is so of course the option D is the correct answer. Now we need to verify that there is a unique alpha such that y of 1 equal to 2 implies y of 1 equal to 2. 2 equal to 1 by e raised to alpha. Alpha into 1. Okay, so what you will get? 1 is equal to 2 e raised to alpha. 1 by 2 is equal to e raised to alpha. Alpha is equal to log of 1 by 2. Yes, that is the value. There is a unique value. There is a unique alpha such that y of 1 equal to 2. So option D is the correct answer. Option D is the correct answer. I think you understood this. It's a 1 mark question. 1 mark question from JAM 2023. Is it clear?
Yes, sir.
This is the second problem. This is again from JAM 2023. I will read the question. Consider the family of curves x square. This is the 2 mark question. Consider the family of curves x square plus y square is equal to 2x plus 4y plus k with a real parameter k greater than minus 5. Then the orthogonal trajectory to this family of curves passing through 2, 3 also passes through. Okay. So, yeah, what they given? They given that curve is x square plus y square is equal to 2x plus 4y plus k. 2x square plus y square is equal to 2x plus 4y plus k. So just I am differentiating first. First I need to find consider the family of curves x square plus y square plus 2x plus 4y plus k with a real parameter k. Then the orthogonal trajectory to this family of curves. So first I need to find the slope of the given family of curve. then I need to replace the slope of the orthogonal trajectory. So first, what I need to find? First, I need to find the dy by dx from this given family of curves. So just I need to differentiate this equation throughout this equation. So I will get 2x plus 2y dy by dx, 2y dy by dx is equal to 2 plus 4 dy by dx. K is a constant, so that becomes 0. Just I am cancelling 2x plus y dy by dx is equal to 1 plus 2 into dy by dx. So I need to find the dy by dx from this. So what I have? Y into dy by dx minus 2 dy by dx is equal to 1 minus x. From this, y to dy by dx is a common. Y minus 2 dy by dx is equal to 1 minus x. From this, what I can say? Dy by dx is equal to 1 minus x divided by y minus 2. Yes, this is the slope of the given family of curves. So next, what I need to do? I need to replace the slope of the orthogonal trajectory. For that, just replace dy by dx by minus dx by dy. Then you will get the slope of the orthogonal trajectory. We know that m1 into m2 is equal to minus 1. From that, I can that is the basic fundamental of the slope of the orthogonal curves. So from that, I can say this is equal to minus dx by dy. It's equal to 1 minus x divided by y minus 2. 1 minus x divided by y minus 2. So what I have now? Dx by dy is equal to I am sending minus in the right hand side. Minus this become x minus 1 divided by y minus 2. So dx by, now I can solve this by variable separable method. The first question also I solved by using variable separable method. See, that is the method we studied in +2 also. So it is a simple method. So dx by x minus 1 is equal to dy by y minus 2. Integrate on both sides. So what you will get? You will get log mod x minus 1 is equal to log mod y minus 2 plus log mod c. So yeah, this I can written as, or if I am adding log c in the right hand side, so what I can write? Sorry, left hand side. Y minus 2 is equal to c into x minus 1. Just I am adding, or this I took here and I kept as a c1, or this I just c1. Then I taken the left hand side, then minus log c1. Okay, that just I take some other constant, c into x minus 1. I can add wherever I want. So c into x minus 1. Y minus 2 is equal to c into x minus 1. So what I have? Y is equal to c into x minus 1 plus 2. This is my curve. Now they are telling that the orthogonal trajectory to this family of curve passing through 2, 3. See, it passing through 2, 3. So just substitute that value and found the value of c. So whenever y value is 3, c into x value is 2. 2 minus 1 plus 2. So 2 minus 1 is nothing but c. C is equal to 1. So what is your solution? Y is equal to x minus 1, y is equal to x minus 1 plus 2. X minus 1 plus 2. X minus 1 plus 2. See, which point now will satisfy this? Means y is equal to x plus 1. Y is equal to x plus 1. That is your curve. So which one will satisfy? Okay, 3, 4. If x is 3, you will get 4. Yes, this will satisfy. Minus 1, minus 1. No. If x is minus 1 plus 1, it becomes 0. So this is wrong. 1, 0. If x is 1, you will get 1 plus 1. Y is 2. So this also wrong. 3, 5. If x is 3, then you will get 3 plus 1. Means 4 you will get. So this also wrong. So only option first is the correct option. And it have 2 mark question. This is the 2 mark question. Is it clear? Is it clear?
Yes, sir.
Is it easy problem, right? Both are easy, right? Yes or no?
Yes, sir.
Okay.
Yes, sir.
In the first problem, we did through variable separable method. And it is the solution of the IVP, initial value problem. First, we have the general solution. From that general solution, because of the initial condition, you took the values constant. So that is a particular solution of that. And the second one, this is orthogonal trajectory. In orthogonal trajectory, what you need to do? First, you have the family of curves. First, found the dy by dx, slope of that. Then if you want the orthogonal family, you just replace the dy by dx by minus dx by dy, because m1 into m2 is equal to minus 1. Then again you will get the differential equation. You solve the differential equation, you will get the orthogonal trajectory. Okay, now I'll move to the next problem.
So,
Yes.
in the orthogonal trajectory, we have to put minus 1 by dy by dx, right? So, dx by dy will be y minus 2 by 1 minus x, right?
Yes, sir.
Again, once again you tell.
So, dy by dx is x minus 1 by y minus 2. So, when we make it dx by dy, it will be like y will be on the top, right? Y minus 2 by x minus 1.
Okay, I will tell you. Yes, here what we have, dy by dx is equal to 1 minus x divided by y minus 2. Agree? Agree?
Yes, sir.
Yes, sir.
Okay. I am not finding from here. What I am doing? See, this is the curve. This is the curve. In this curve, I have dy by dx. The slope of this curve, I have 1 minus x divided by y minus 2. In this curve, I have the dy by dx. Slope of this curve, I have 1 minus x divided by y minus 2. Now, what is my question? See, if I want to find the orthogonal curve of this. Orthogonal curve means the perpendicular to this. Some, okay, like if this is the curve, okay, just I need to find the perpendicular curve of this. See, this is the dy by dx. Dy by dx is equal to 1 minus x divided by y minus 2. Okay, now I need to find the slope of this curve. For that, what I am replacing, I need to replace this dy by dx by minus dx by dy. In the sense, what I need to tell you is nothing but, see, I want to see the slope of the orthogonal curve and not the first curve. Okay, so that I am replacing minus dx by dy. You got it?
Sir, can you please explain it again?
Okay. Tell me, ask your question again.
Sir, dy by dx is the slope of that curve in U shape.
First curve. You can tell this curve. Okay. Then
sir, the orthogonal trajectory will be the perpendicular.
yes, perpendicular one. Right.
It should be -1 by this, like reciprocal. Like,
I don't know, some disturbances are coming. Okay, again. Yeah, now it's fine. Yeah. Again, you ask.
Like for orthogonal trajectory, like shouldn't that be minus of y minus 2 upon 1 minus x?
Yes, correct. Like this. If you can tell, if this is M1, this is M1, this is slope M1, this is slope M2, then M1 into M2 should is equal to -1. So if this is dy by dx, this is
yes,
M2, this is M2, then this is -1. So M2, I can tell -1 by dy by dx. Means minus dx by dy. That minus dx by dy I am replacing here. That is the slope of the orthogonal trajectory.
Okay, sir.
Is it fine now? So just I am replacing dy by dx by minus dx by dy. So only thing is, first of all, you have the dy by dx. That dy by dx is the family of the original curves. Now, if you want the slope of the orthogonal curve, just replace. Okay, first of all, you have M1. Now that you need to find the M2. So what do you to do? You just replace dy by dx by minus dx by dy. Okay, you
sir.
just go through that. Then maybe some more clarification you will get it. Okay. Yeah. This is the next question. Yeah. I will read the question. Let y from R to R be a twice differentiable function such that y double dash is continuous on closed interval 0, 1 and y of 0 is equal to y of 1 is equal to 0. Suppose y double dash of x plus x square less than 0 for all x belongs to closed interval 0, 1. Then y of x is greater than 0 for all x belongs to closed open interval 0, 1. Y of x is less than 0 for all x belongs to open interval 0, 1. Y of x is equal to 0 as exactly one solution in open interval 0, 1. Y of x is equal to 0 as more than one solution in open interval 0, 1. Okay, so say this. Okay, just I am taking this differential equation d square y by dx square plus x square. Just I am finding the solution first of all with equal to 0. So what I have now? D square y by dx square is equal to minus x square. So second order linear differential equation with constant coefficient. It's a second order and linear a differential equation with constant coefficient. So first I need to find the YC, complementary solution. For that I need to find the auxiliary equation. It is in the form of operator form, d square y is equal to 0. So then auxiliary equation become m square is equal to 0. Implies it has the double root 0, 0. So y of x is equal to, y of x means yc, c1 plus c2x e raised to 0 x. Generally we know that y of x is equal to, if it is the double root, yc become c1 plus c2x e raised to mx. If it is the distant root, you know yc is equal to c1 e raised to m1x plus c2 e raised to m2x. If it is the complex roots, it become c1 e raised to complex root will exist as a conjugate pairs. So if the roots are alpha plus or minus I beta, then solution become e raised to alpha x a cos beta x plus b sin beta x. Similarly, if it is a rational roots, a hyperbolic function will come. Okay, anyway, y of x, in this case, it become y of x is equal to c1 plus c2x e raised to 0x. Means y equal to y of x is equal to c1 plus c2x. Okay, now I need to find the particular integral. So yp is equal to minus x square d square. So what I need to get? For this operator, first integrate 2 times minus integral x square dx. So minus integral x cube by 3 dx minus x raised to 4 by 12. Yeah. So what is the general solution now? Y of x is equal to c1 plus c2x plus minus x raised to 4 by 12. Okay, then yeah, it is a second order. So you have a 2 arbitrary constants. You have a 2 initial condition. No, 1 initial and 1 boundary. It's a BVP, boundary value problem, because the conditions are given in 2 different places. So y of 0 is equal to 0. So implies 0 is equal to c1. Both have c1 is equal to 0. So your solution become y of x is equal to c2x minus x raised to 4 by 12. Now y of 1 equal to 0 implies 0 is equal to c2 minus 1 by 12. c2 you will get 1 by 12. So what you have y of x? Y of x is equal to 1 by 12 into x minus, so x minus x raised to 4. That can be, if you take x as a common, x into 1 minus x cube by 12. Just if y of x is equal to 0, then what you will have? You will have 1 minus x cube is equal to 0. Means x cube equal to 1. Cube root of unity. The solutions are 1 omega square. This omega and omega square as a complex solution. Is your y from R to R is a real function. So you see y of x has more than one solution in more than one solution in I of x has more than one solution in open interval 0, 1. No. Y of x has exactly one solution in open interval 0, 1. No, that also wrong. Y of x is equal to 0 has more than one solution in open interval 0, 1. That is wrong. Y of x has exactly one solution. It's an open interval. If it is closed interval, then it have exactly one solution. Y of x is less than 0 for all x belongs to 0, 1. Y of x is greater than 0 for all x belongs to open interval 0, 1. Just let's see that two option. Okay, just I am taking one interval like between the 0, 1. I need to see the what is it less than 0 or greater than 0. So just I'm taking 1/2. Then what was our y of x? What is the nature of y of x in this interval? I think 1/12, 1/2 minus 1/12. Okay, anyway, 1/12 1/2 1 minus 1/2 the whole cube. The first quantity is positive. Second quantity also positive. Is a again will decrease. Or see 1/2 the whole cube. Power is you are taking. The entries between 0 to 1. If you take, it will still decreasing. So it is positive only. All the quantities are positive. So I guess y of x is greater than 0 for all x belongs to open interval 0, 1. So this is the correct answer. Option A is the correct answer. Option 1. Option 1 is the correct answer. It's not an MCQ section. I think it's a only single option is correct. Yeah. Y of x is always greater than 0 here. Is it clear? I think you also just go through that.
Sir, could you explain the fourth option once again?
See, I have what is my y of x? X into 1 minus x all cube divided by 12. If I take it is 0, I will get one solution x is equal to 0. It's a fourth degree polynomial, right? And another one is 1 minus x cube is equal to 0. 12 never be 0. So x equal to 0. 1 minus x cube equal to 0 implies x cube equal to 1. So cube root of unity means what are the solution? I can solve x cube minus 1 is equal to 0. Means x minus 1 into x square plus x plus 1 is equal to 0. Implies you will get x minus 1 equal to 0 or x square plus x plus 1 is equal to 0. Implies x equal to 1. If you solve this, you will get minus 1 plus or minus root of b square minus 4ac. 1 square minus 4 into 1 into c. 1 square minus, I think minus 3 divided by 2 implies you will get minus 1 plus or minus root 3i by 2. This is the omega or omega square. These are the complex roots. So what are the solution you have? X equal to 0 or x equal to 1. These two are not there in this interval. This is because this is an open interval. So these two options are incorrect. Only you need to check the above two. From that you got is always greater than 0, because in between 0 to 1 you have the positive numbers, and your x cube is still less than 1. It's never be increased, because you are taking the values in between 0 and 1. So 1 minus x cube is always positive, x also positive. So product of two positive is positive, divided by a positive number is positive. So so that you can conclude y of x is greater than 0. Next is the numerical type question. NAT problem. Numerical answer type question. What was the question? If y is the solution of y double dash minus 2y dash plus y is equal to e raised to x. Y of 0 is equal to 0. Y dash of 0 is equal to minus 1 by 2. Then y of 1 is equal to dash round of 2 decimal places. Round of 2 decimal places. S. Given differential equation y double dash minus 2y dash plus y equal to e raised to x. It's a second order linear differential equation with constant coefficient, and they are given because it's a second order. So getting the particular solution, they given two conditions. Y of 0 is equal to 0, y dash of 0 is equal to minus 1 by 2. Okay, first I need to find both complementary solution and particular integral. For that, I am writing in the differential operator form, d square minus 2d plus 1y is equal to e raised to x. From this, I am finding the auxiliary equation, m square minus 2m plus 1 is equal to 0. Means m minus 1 whole square equal to 0. Implies m equal to 1 comma 1. It's a double root solution. Already I told the complementary solution of double root c1 plus c2x e raised to mx. Mx means e raised to x. Now I need to find the yp, particular integral. Yp equal to e raised to x divided by d square minus 2d plus 1. Yeah. Whenever e raised to ax is coming, you just give the value of a in differential operator. So what we'll have here? D square minus 2d plus 1 ile a the value e raised to ax. Here a is equal to 1. So 1 square minus 2d plus 1 means 1 square minus 2 plus 1. 2 minus 2 becomes 0. So you differentiate it and just give x here. X e raised to x, differentiate this. 2d minus 2. Then you substitute again the value of a. Then 2 minus 2. 2 into 1 minus 2. Again 0. Then again you multiply with x and differentiate it. X square e raised to x. Derivative of 2d minus 2 is 2. So you will get, this is the particular integral. X square e raised to x by 2. So what was your general solution? Y of x is equal to c1 plus c2x e raised to x plus x square e raised to x by 2. Okay. Now what was the condition? Y of 0 is equal to 0. Y of 0 is equal to 0. Okay. Then y of 0 is equal to 0 implies, first condition, y of 0 is equal to 0 implies 0 is equal to c1 c2x becomes 0. C1 equal to 0. You will get very easily c1 equal to 0. So y of x become now c2x e raised to x, x square e raised to x by 2. See, another condition, y dash of 0 is equal to minus 1 by 2. Y dash of 0 is equal to minus 1 by 2. So, differentiate this. Y dash of x. Y dash of x is equal to C2 is the constant. Differentiation by product rule. First into derivative of second, second into derivative of first, plus 1 by 2 first into derivative of second, second into derivative of first, 2x. They are given y dash of 0 is equal to minus 1 by 2. So minus 1 by 2 is equal to C2. First term gone, e raised to 0. Second complete term is gone. So C2 is equal to minus 1 by 2. So what do you have now? Y of x. Your y of x become equal to y of x is equal to, yeah, minus 1 by 2 x e raised to x, x square e raised to x by 2. Substitute y dash, y of 1. Y of 1 equal to minus 1 by 2. 1 into e raised to 1. Because e will come. 1 square is 1, e by 2. Minus e by 2 plus e by 2, 0. So your answer is 0. Is it correct? Is it clear? So they may give ranges like this. They may in the key they may give minus 0.01 to 0.01. Of course, accurately you can give the value as 0. So you will get the full mark. I think this is a 1 mark question. So numerical type 1 mark. Clear? Yes or
Yes,
no?
sir.
Okay, fine.
Yes, sir.
Yeah. Next. Another problem. See, nearby 10 mark. 10 mark will come in ODE section, 10 to 11. So if you get a good mark, good score, good ranking, you just score 7. Approximately 7 to 8 mark. Always, otherwise
Sir?
you just follow up. Yeah. Yes.
Sir, will you suggest any books for OD, not for JAM perspective, for general studying OD?
I think lots of books are available. Let me tell you after the class. Let me tell you, okay?
Okay, sir.
I think more than me, maybe Vinod sir can give good reference for you.
Oh, okay, sir.
Yeah. I will give, definitely I will give. Yeah. Next problem. Yeah. Yes. It's a numerical type, but it's a 2 mark question. Let y from 1 to infinity, open interval 1 to infinity to r, be the solution of the differential equation y double dash minus 2y 1 minus x whole square is equal to 0, satisfying y of 2 is equal to 1 and the limit x tends to infinity, y of x is equal to 0. Then y of 3 is equal to dash round of 2 decimal places. Yes. See. Yeah, question is fine. Can I go to the answer? Can I move to the answer?
Yes, sir.
Yes, sir.
Okay. See, then y double dash minus 2y 1 minus x whole square is equal to 0. Multiply throughout by 1 minus x square. 1 minus x whole square y double dash minus 2y is equal to 0. Can anyone tell the form of this DE? It is some special DE. It has some name. Anybody? Anybody?
Bernoulli.
No, it's not a Bernoulli. Bernoulli will come like y square, y raised to n, like that. Yeah, I will tell you. This is a Cauchy-Euler equation. It's a special type of Cauchy-Euler equation. Generally, Cauchy-Euler equation will come like this. X square y double dash plus x y dash plus y is equal to some 0, like this. But it is transformed, some more ax plus b. You see, it's like this. Ax plus b whole square y double dash x plus b y dash plus y equal to 0. Of course, it's a Cauchy-Euler equation only, but we can reduce such a type of Cauchy-Euler differential equation to general Cauchy-Euler differential equation. See, whenever x square y double dash plus x y dash plus y equal to 0, we will give the transformation x is equal to e power z. X is equal to e power z. But now I am going to solve this one. Yeah, let us see how to solve this. Yeah, you see here, generally whenever x square y double dash x y dash, in that time we will give x is equal to e power z. But whenever this is the format, you just give 1 minus x. 1 minus x is equal to e raised to z. So you will have z equal to log of 1 minus x. Generally, you will get x is equal to e power z, z equal to log x. But here 1 minus x whole square is there. See, general form is nothing but in the same case, x square y double dash minus 2y is equal to 0. But instead of x here, it is 1 minus x is there. So you just transform e raised to z as a 1 minus x. So z equal to log of 1 minus x. Then first you need to find the dy. dy in the sense dy by dx. dy by dx is nothing but dy by dx is nothing but dy by dz into dz by dx into dz by dx. So what was the dy by dx here? Sorry, dy by dz, that we don't know. That you took some d1. dz by dx is nothing but 1 by 1 minus x into minus 1, because it's log 1 minus x. So minus 1 by 1 minus x into dz by dx. This is the dy. This, if you want, you can take dz by dx as a d1. No, dy by dz. It's wrong. Wait. This is dz by dx. I found minus 1 by 1 minus x. Remaining what is there? dy by dz. dy by dx is d, differential operator capital D. dy by dz is d1. Okay. Next is the d square y. D square y is nothing but d by dx of dy by dx, means d by dx of dy by dx is nothing but minus 1 by 1 minus x into dy by dz implies, yeah, first into derivative of second. Yeah, this means what you will get? D square y by dz square into dz by dx, because z is again a function of x. So dz by dx. First into derivative of second plus second into derivative of first. Okay. Yeah, that become negative is already there. 1 by 1 minus x is nothing but negative is already there. Derivative of 1 by x is minus 1 by x square. So minus 1 by 1 minus x whole square into derivative of minus x. 1 minus x is again negative 1. Okay. So yeah, dz by dx is nothing but dz by dx is negative 1 by 1 minus x into minus 1, means negative 1 minus x. If you multiply both, you will get 1 by 1 minus x whole square d square y by dz square plus minus minus plus. Anyway, negative will come. Negative 1 minus x whole square dy by dz. Okay, that is the d square. Multiply throughout 1 minus x whole square. So 1 minus x whole square d square y equal to, yeah, this operator I am taking d1 square. d1 square minus d1 y. Okay. Yeah. So what is your original ODE? 1 minus x whole square d square y minus 2y equal to 0. This is your the first original ODE. Now after transformation, now it become 1 minus x whole square d square y become d1 square minus d1 minus 2y equal to 0. Okay, now it becomes d1 square minus p1 minus 2y is equal to 0. So now you can find the remaining auxiliary equation. So it become equal to m square minus m minus 2 is equal to 0. So I need to factorize. This is nothing but m minus, for a product you should get minus 2, for addition you get minus 1. So m minus 2 into m plus 1 equal to 0 implies m equal to 2 or m equal to minus 1. So your y of x is equal to c1 e raised to mx, mx, not mx, mz plus, because now z is your variable, c2 e raised to minus z. Z is nothing but log of 1 minus x. So c1 e raised to log 1 minus x to whole square plus c2 e raised to minus log 1 minus x. This is equal to e raised to log x is x. So c1 1 minus x whole square. This is log 1 by 1 minus x. So c2 by 1 minus x. This is your y of x. See, they are given that, they are given the condition now, limit x tends to infinity. See, they are given the condition, limit x tends to infinity, y of x should be 0. X tends to infinity, y of x should be 0. Yeah. If I apply the limit x tends to infinity, y of x is c1 1 minus x whole square, c2 by 1 minus x. This is your y of x. Okay. If x tends to infinity, the second term c2 by infinity will come. C2 by infinity, something divided by infinity. Yeah, there is a chance to 0, no issue. But if you apply the first term as infinity, then yeah, there is goes to infinity. There is a chance to goes to infinity. Then only one condition. Only now we can do only one thing. What is that? C1 should be 0. Then only limit x tends to infinity, y of x becomes 0. Otherwise, no. So c1 should be 0. So what is your function now? Y of x is equal to c2 divided by 1 minus x. Okay, now apply the second condition. Y of 2 is equal to 1. If y of 2 is equal to 1, then 1 equal to c2 by 1 minus 2. Means minus c2 is equal to minus 1. You will get c2 is equal to minus 1. So your y of x become now minus 1 divided by 1 minus x. So what you want? You want y of 3, value of y of 3. Y of 3 is equal to minus 1 divided by 1 minus 3. Minus 1 divided by minus 2. Means you will get 1 by 2. So approximate value is 0.5. 0.50. Okay. Up to 2 decimal places. So 0.50 you should write. Is it correct? Is it okay?
Yes, sir.
Okay. Then remaining we will do in next section.
My name is Shikha Kumari, and I've completed my integrated MSc from in Mathematics and Computing from Birla Institute of Technology, Mishra, and I'm from Jharkhand. So your session was really very nice, and it was very clear. Each and every step was clear, and so thank you for your time, and looking forward for the more session from your side, sir. Thank you, sir, and thank you, Vinod, sir, for organizing such sessions.
The session was very nice, and last problem 1 minus x square type, very good problem. You can tell, sir, books about for preparation ODE.
Yeah, I think one student is asked, Rising Ania you can follow. Rising Ania. You can follow that book.
Yeah, that's a nice one with lots of worked out problems. I think, Dharmendra, that book was being shared in our group too. You can check it.
Yeah. Before some days ago, I see.
Yeah.
And SL rows, how much difficulty in SL rows?
Yeah, the level of difficulty may change according to the students, I think. Yeah, you can anyway. You can go try to go through it.
In my BFC, I followed Kirtana series.
Yeah.
Thank you, sir. Thank you, Vinod, sir.
Okay, Dharmendra. Yes, others.
Hello, sir. I'm Minsia from Govt Victoria College, Palakkad. Your class was very nice and was very easy to catch. Thank you, sir, for spending your valuable time with us, and thank you, Vinod, sir, for arranging such a class for us. And I'm hoping more classes from you. Thank you, sir.
Yeah. Yes.
Thank you, Minsia.
Thank you.
Hi, sir. I'm Zahra Rumaisa from TMC College, Tirur. It was really nice session, sir. Very easy to understand. And thank you, Vinod, sir, for conducting this valuable session. Thank you once again.
Thank you, Sarah. Yes, others.
Hello, sir. I am Nazmia. I am a third year BSc Maths student from Sasit College, Kerala. So all the questions were well explained. Thank you, sir, and thank you, Vinod, sir, for arranging this session. Looking forward to have more sessions with you, sir. Thank you.
Okay, thank you, Nasmia. If any of you would like to share a comment, please make it do now.
Hi, sir. I'm Aninda from St. Joseph's College at Ernakulam. So the session was so nice, and all these topics that we are currently studying in our syllabus, it gave me more knowledge about the topic that teachers is taking in my own class. And your presentation was really nice, sir. And thank you for this class. Thank you for arranging this session.
Okay, thank you, Ananda. Okay, thank you, Rafeek, for this nice session. We can arrange another one after some time.
Yes, sir. Thank you.
Yeah, it will be better if you can give the workout of the problems, if possible.
Yes, sir.
Along with PDF, we can share it after the class. Okay.
Yeah. Yes, sir.
Okay, thank you. Thank you, everyone. Bye.
Thank you, sir.